Good morning. I'm Connor. I'm here with Liz, Joseph, and Michael. Together we are JMCE, and today we are proud and excited to share with you the Cooleidoscope, a fully open source, all-in-one thermal and lighting effect control system for desktop gaming PCs, complementing the water cooling loops that enthusiasts often use to keep their systems cool. It's built on a Raspberry Pi, which hosts a time series database to collect all of the sensor data, a Maria database for the user settings, custom Python libraries to interface with each of these sensors. We use the Pi GPIO library to drive these sensors and collect data. The Raspberry Pi also handles the LED animations. The library that we use to drive the LEDs utilizes one of the two available PWM pins on the Raspberry Pi. Because we have 3 different fan zones that we want to control, we also make use of an Arduino, which sits on top of a custom designed PCB hat. The Arduino and the Raspberry Pi communicate over I2C. We also use the Arduino to collect data on an analog sensor that measures the current draw of the Cooleidoscope and the LEDs. To present all this data to the user, we have a Flask and JavaScript-based web UI, which I will hand off to Liz.
So the web UI offers users the ability to control fan speeds and also set LED animations. And then we also offer some features we offer to users is they can directly view the performance of their PC through the settings overview page, which we'll see on the top right here. You can view the temperature data, the current sensing, and then you can also see the RPM of the fan and pump. And then we also have a settings page where users can customize and fine-tune LEDs and fan speeds to their needs. So in the LEDs, you can set the brightness, change the LED animations, and also change the speed of the animations. And then we also have a fan control setting where users have 3 options. They can use the manual setting to manually tune the fan speeds, or they can use a stair-step function where they can individually input the temperature and the fan speeds. And then lastly, our PID for advanced users, where they can really fine-tune the fan speeds to their system. And this is, like Connor said, all locally hosted on the Raspberry Pi, which is part of the Cooleidoscope.
So,
yeah.
Do you have any questions?
Yeah, what particular components are you trying to keep cool?
Whatever the user has hooked up to their cooling system. So this is a complement to an existing water cooling loop. They can cool the processor, the graphics cards, and these days even the north-south bridges of the motherboards themselves.
Is there a noticeable difference for the user? I noticed you said you outperformed the heatsink system by 14%.
Mm-hmm.
Can you see the difference when you're actually using it and
Yes.
gaming it? Is it just appear faster, slower? Or what differences do you physically see?
The physical differences is you can achieve higher clock speeds with the CPU because you're cooling it that much more effectively.
Okay.
So you get more performance out of your computer.
So the graphics actually, can you notice it when you're looking at it, or is it hard to see it?
When you turn the graphics up, your system would slow down, but if you overclock your system, it doesn't slow down as much.
Okay.
So did you?
I had a question on, 2 questions. One, do you have your own sensors or do you use the sensors that are in the machine? And I can't understand, is this a water cool system or a fan cool system? I'm not clear with that. There's a couple of those 2 questions.
We control the fan speeds of the fans on the radiators. So it is
the
a
fan's
water
already
system.
there.
Correct.
And you have to hook into their fans?
Right.
And do the sensors, temperature sensors already there too?
We actually use one-wire sensors, Dallas one-wire sensors.
Okay, so you run the sensors out, okay,
Right.
and put them all the places that you're looking for temperature, and then you hook to their water cooling system and run the fans on their water cooling system? Or?
Correct, yes.
Okay, I got it.
So how do you design the web interface?
A lot of hand done JavaScript.
Yeah.
Yeah, on the same question, is it a one-time setting, you change it, or it has to be done on a regular basis, while you're answering her question?
You can change it whenever, but it's, yeah.
Yeah, go ahead.
It runs completely independently
Right.
of the host computer.
Sorry.
Yeah, so the web interface, so what was your idea behind that? How did you design it?
We had some ideas of what data we wanted to present to the user and what
settings we wanted to offer to the user.
Yep.
So those were our options when we created the
So they can
interface.
control and visualize what's happening as well?
Right.
Okay.
Alright, one last.
What
Two
kind of-
more.
What kind of fail-safes does the program have?
The fans fail to 100%. So if the system isn't running, the fans go to 100%, and that's it.
One last one.
And does this just use ordinary tap water, and is it a closed-loop cooling system?
It is a closed loop, and ideally you'd use distilled or provided coolant.
Alright, let's thank the team.